Hello everyone. Today I'm showing you our third assignment, which is based on the different algorithms, which helps to find the it's basically the path planning, and there are number of algorithms which are available to do that. So specifically, there are two types of algorithms which we are using in this project. The first one is D-star algorithm. So this is nothing but this is the basically the class in which I write all the codes. And if I want to check the D-star algorithm, so that this is processing the D-star algorithm now, and there is basically different maze which are building in the graph. So it will find the path between by its given start position to end position. So basically this is the path which is created by the D-star algorithm, and this is its start position and this is its end position. So our next algorithm is basically the PRM algorithm, which is more faster than the D-star algorithm because it's made of a different nodes. We are given 300 nodes in this map, so that it will find the proper path which will avoid the longer nodes, achieve its shorter nodes, and giving us a destinations, which is it will search its goal positions and start positions based on our inputs, whatever the maze which we want to select, or whatever the goal positions we can select in the GUI. I'm going to show you. Okay, so this is the proper map which is created using the PRM algorithm, and this thing is nothing but the different nodes which we are generated in the PRM algorithm. So it's basically the search, it's find the path, and you can check here that it's between only few nodes it's giving us proper path from its start positions to goal position. So right now we can check all its implementation and its algorithms in proper GUI format. So how basically it's run. So this is my proper GUI. This is the function for the create robot. This is to select its initial positions. This will give us end effector positions that according to the robot is going to move. This is for the connect Arduino. This button is for the disconnect the Arduino from the hardware. This function is to load the map in the GUI. This function is draw in whether you want to draw the paths in GUI or in a board. So this is for the GUI and this is for draw on board. And here we can select our algorithms based on our algorithms which we want to implement. And here are smoother options so that our path will get more smoother and it will avoid the connection in the nodes. So there are different algorithms which is interpolation, basically interpolation algorithms which are available. So mainly there are 4 differences, which is no interpolation, T-poly, LSPB, and quantic T-poly is the algorithms that we are going to use. This thing is for the LED position, so it will show us our LED status, which is LED is on, green LED is on, or red LED is on. This thing is for the start positions. This is our maze, maze 1, maze 2, maze 3. Based on these pointers we can select our maze. Okay, and this is our main function which we'll use for the path planning. So after creating here, we can show our actual path. So right now I'll just create a robot first. This will be my initial position only. So this will load my map in the basically in GUI. If I give a command in draw in GUI, then my robot will start to draw exactly the replica of that maze, or basically the map of maze in the GUI. So here we can see that our robot is drawn the exact replica of the map which is given in a GUI. So here is a map. Okay, so if I want to implement the D-star algorithm with the no interpolations, without any interpolation methods, and here I can select my start position. So basically I'm starting my maze 1 as for the start position, and if I start to implement the path planning, so it will again show us like D star algorithm, like how it's exactly going to draw from its, like maze 1 is nothing but the positions 1 to the its goal position. So here we can see that without any interpolation, our robot is drawing from, this is basically my positions which are selected, and the goal position is fixed, means it's a center position, so it will always go to its target, which is the goal position. So here we can see that it's drawn the proper map. Now we can calculate the exact timing which will like taken in the position. So here like 56 seconds required to draw the exact map from its start position to goal position. Here I am selecting the D star method using, now I am selecting the T poly as an interpolation, and maze 3 as my like starting position. And if I give the command path planning, so it will draw basically using the interpolation method. Right now we are like giving only 3 points between the each and every, like nodes which is D star is connecting. So like T poly will consider like from 1 node to 2 node, it will consider 3 steps, and maybe the time is like it will take lots of time than the normal interpolation method without interpolation method, but this path is like more smoother and it will not take any distractions while it's drawing from its start position to initial position. So here we can see that T poly is drawing the like more smoother path. Like here is like basic simple change, or here you can check that like it's giving us like shortest path over here from its start goal position to end position, and exactly our robot is also drawn the same thing in the GUI. And now we can check our timing. So it's basically taking like lots of timing without the interpolation, but as I said before, it's the most convincing method to draw. Now the next interpolation method is LSPB. So we can check, and I'm selecting my start position as a maze 2, and basically it's giving the, it's like existing the D star algorithm using the LSPB as an interpolation method. So here the graph started to draw the path from its start position, which is already like given, and it goes to its goal position from start to end. So here we can check that the LSPB is giving us like most shortest path without like it's avoiding the modes of its nearby nodes, and it's avoiding its longest nodes, achieving its nearby nodes, and it's drawing in a map. And we can check that so time required for this is like 137 seconds to draw a map. Now we are checking our next main algorithm, which is PRM. Basically I'm not selecting here any interpolation method for the beginning. So now I'm selecting maze 3 as my for the start position, and if I start to path planning to find from its start position to goal position, so it will select. The important thing about the PRM that it's like achieving its shortest nodes, like, and it's giving us the which is the shortest path, which is like more different than D star algorithm. So basically it's like draw the path over here from like this to here, which is from this is the third position to this is the, and these are the different nodes which is created by the PRM algorithm. And the time required for this it's like I already told that it's the shortest time consuming algorithm, so it's taking only 56 seconds to reach its destination position. So our next step is to select the PRM as a main algorithm, and I'm selecting your T poly as a interpolation method now, and I'm selecting maze 1 as for my start position. And if I draw the path, if I give a command, so it will start to draw the path. So here in T poly algorithm, it's giving me like more number of nodes between like as compared to previous nodes, and it is giving from start position to end position, and the time required for this algorithm is like 63 seconds, which is like small, like greater than the normal PRM algorithm, like without interpolation algorithm. So now the next step is to draw the PRM algorithm, and I'm selecting LSPB as an interpolation method, and again I'm giving like maze 1 as my start position, and it will start to draw the path. And here is the path which is drawn by PRM as algorithm and LSPB as an interpolation method, and the time required for this algorithm is basically 62 seconds. Now our final algorithm is like I'm doing D star algorithm using the new interpolation method, which is quintic T poly. I'm selecting this as a start position, and now our algorithm will run based on the quintic T poly as an interpolation method. So this is quintic T poly as an interpolation method, and here you can see the path, and the time required for this interpolation method is 140 seconds. Now here I have shown all the 2 types of algorithms and the interpolations, 4 types of interpolation methods, which is like no interpolation, T poly, LSPB, quantic T poly, and here I have already shown as per the assignment's requirement. I already shown all the interpolation and algorithms which is required to draw a robot. Thank you so much for watching this video. If I created a robot and select at this as an initial position and use this command for to connect the Arduino and this the load map, and if I start as a D star and select as a no interpolation and my start position as a maze 1, I can start the path planning over here. We can see it in hardware. So here we can check that now the LED status is red because it's away from the light, and as our sensor is trying to move toward the right, towards the light, the LED status will start changing from red to green after the movement. So right now it's red. Okay, so here the robot is slowly moving towards the light, which is its goal position, and so here you can check the LED status, which becomes green after reaching to its goal position, which is green right now after achieving its position. So LED status is changed from red to green.